Now we're going to work some problems where we're going to be given a complex number in rectangular form, and we're going to first we're going to plot the number in the complex plane, and then we're going to convert the rectangular form into the polar form of a complex number and then the exponential form of a complex number. So let me just show you the problem. I'm not going to work it on this sheet of paper, but so you understand it when you get to the homework. So here, plot the complex number on the complex plane and write it in polar form, exponential form. So here's a complex number in rectangular form. They want you to plot it. Pretty simple to do. I'll do that in a minute. But let me just read this, and then I'll go ahead and work this problem out. Write the complex number 7 minus 7i in polar form. So we're given a complex number in rectangular form. We want to write it in polar form. And as it turns out, they give you 4 choices here. So this first box is where we're going to put the r, and then these 2 boxes, it's where the theta belongs. I don't know why they gave you 4 choices. Obviously, the polar form is cosine of theta plus I sine of theta. So it has to be choice B. But let's read on. So you put it in polar form. Select the correct choice below and fill the answer. Now, simplify your answer. Type an exact answer. All right, exact answer. This means this is probably going to be a special angle if they want an exact answer. And we're going to use pi as needed. Type any angle measure in radians, so with the answer to be in radians. Use angle measures greater than or equal to 0 and less than 2. So that's important. They want the angle, they want theta to be between 0 and 2 pi. And use integers or fractions expression. All right, just so you know, when you get to these kinds of problems, that's how they word it, and it may not always make sense sometimes. So that problem, the complex number, so this is in rectangular form. I'll just quickly plot it over here. So of course this is the real axis. This is the imaginary axis. So 7 and then negative 7i, so if 7's here, negative 7i. So we would say this point down here is 7 minus 7i. All right, pretty simple. Now, let's write this in polar form. Now, the standard equation of a complex number in polar form, it's r cosine of theta plus I times sine of theta. So in rectangular form, x plus yi. So x is 7, y is negative 7. So what we have to do to rewrite this complex number in polar form, we have to figure out r and theta. And we're going to do that. Well, let's just go and do it. R, it's this little formula equation we've used before, square root of x squared plus y squared. So x is 7, y is negative 7, but we square it. So 49 plus 49, square root of 98. So we say r squared 98. However, in math, we always have to simplify these radicals, and this can be simplified. I'll just do this once. 98 we can call 49 times 2. Square root of 49 comes out as a 7. So actually square root of 98 is 7 times square root of 2. So r is 7 times square root of 2. So we've got the r. Now we just need to find theta, and we find theta, we can rewrite this complex number in the polar form. So our equation to find theta, let's go and try this one where we have inverse tangent of y over x. Now, inverse tangent is sort of tricky. Now I know my point here is like in the fourth quadrant, so I have a pretty good idea. My angle is actually going to be this right here. So when I figure it out, I can visualize this and make sure I have the correct angle. So y is -7, x is 7. So really, I have the inverse tangent of -1. So for inverse tangent, we ask ourselves the question, what's the angle where the tangent is -1? You can think of it like this. And I'm going to go ahead and do this since we're not limiting ourselves to the inverse functions. We want the answer to be from 0 to 2 pi. Let's think of it like this. So when we look at the unit circle, what are the angles where the tangent's -1? Well, if you remember, we like to think of tangent as sine over cosine. Well, sine and cosine have to be the same number but opposite signs. So we know that at the opposite signs would be 3 pi over 4 or 7 pi over 4. Obviously, the angle is going to be 7 pi over 4. So now I've determined R, I've determined theta, so now I can rewrite this complex number in the polar form. So it's R, 7 square root of 2, times cosine of theta, theta is 7 pi over 4, aha. I told you a minute ago that the answer was obvious. Okay, sorry. Since I put plus, what we're going to put here is just let me check something really quick. Yeah, sorry. I want to make sure I didn't make a mistake. So yeah, so the polar form is cosine theta plus I sine theta. So there's the polar form of the equation. Then they asked for a third thing. I could just show you. There's one more box. After we write in the polar form, then they say write that complex number in exponential form. So exponential form, just to remind you, exponential form is very easy to get once you know the polar form, because the exponential form is just simply r e to the I theta. So this is the polar form, this is the exponential form. So once you know r and theta, you've got both the polar and the exponential form. So for the exponential form, r is 7 square root of 2 e to the I, and theta is 7 pi over 4. So there's the exponential form. So we began with a complex number at rectangular form. We found r and theta. Once we did that, we were able to write the complex number in polar form and then in exponential form. Let's do another one. Here's a complex number in rectangular form. 5 square root of 3 minus 5i. I'm not going to worry about plotting it because that's pretty simple. Usually the tricky part can be found in the r and theta. So to get to polar and exponential form, I need to know r, I need to know theta. Well, we know r is the x squared plus the y squared. So this is going to be 25 times 3, 75 plus 25. It's nice. R ends up being 10. So now I simply need to know theta to be able to write this complex number in both polar and exponential form. Let's look at but this is a case just like with polar coordinates. Sometimes there are other options, and I'm wondering, well, let's just do this. We'll just stick with what we've been doing. So we're going to say theta is going to be inverse tangent of -5. So first of all, even though I didn't plot this, I should have at least got an idea. So it's going to be for the real positive and for the imaginary negative. So I know I'm going to be here in the fourth quadrant. That becomes important when I'm trying to find my angle. So y is -5, x is 5 square root of 3. So the 5's cancel. It's really -1 over square root of 3. Now we've done this before. Let's go ahead and do what we did a minute ago. Since I know my angles are going to be between 0 and 2 pi, let's rewrite this and say, instead what we want to do is say let's go find an angle where the tangent is -1 over square root of 3. So once again, since the tangent's negative, we know it has to either be in quadrants 2 or 4, because that's where the tangent's negative. So this is where, once again, when you realize sine over cosine, and you realize those special angles where you have the square root of 3, and I actually need it to be with the cosine. We've done this before, so I'm not going to take time now to explain it. You realize that when theta is, in this case, 11 pi over 6, the cosine is square root of 3 over 2, and the sine is -1/2. And when these cancel out, you get this. So that's going to be my theta. So once you have r and theta, then for the polar coordinate, or the polar version, it's very straightforward. It's r times cosine of 11 pi over 6 plus I times the sine of 11 pi over 6, because theta is in both of these. And then for the exponential form, it's just r times e to the I times theta. Very straightforward. Now let me do one more, because this next one, both these first problems, theta, the angle, ended up being a special angle. But you will have problems where it's not a special angle. As a matter of fact, if you look at the instructions, they changed the instructions a little bit. Let's look at this one. So this one we're going to do in a minute is going to be 3 minus 8i. This is not going to be a special angle. So look at what they say now. Type an exact answer for r. In other words, r they want to be exact. So you might have square roots or whatever. But then they want the angle in radians rounding to 3 decimal places as needed. So whenever you see that in a trig problem, you know that that means it's not an exact angle, and we'll probably have to use our calculator. So let's go ahead and do that one. So this was 3 minus 8i. So this will be our last problem. So here is a complex number, rectangular coordinates. So the real part is 3. Imaginary part's negative 8. So it's like we're still down here, like all these problems end up being in quadrant 4 for some reason. So we need to find r. 3 squared plus negative 8 squared. 9 plus 64. That cannot be simplified. It looks like r. So since they want an exact number for r, that's going to be our r. Now here's where, since we're going to use our calculator, it gets a little tricky. So I'm going to use the inverse tangent of y over x equals theta. You're going to see in a minute, it's easy to use a calculator, but you have to interpret what's actually going on. So y is negative 8. Now I know in a minute, when I go grab my calculator, what I'm wanting as my answer is this angle. But I know, because the way inverse tangents are defined, and my calculator knows that, it's going to give me this number. So I have to think of this as, to get my actual answer, I believe I'm going to have to take 2 pi minus the angle my calculator gives me. So in my calculator, I went ahead and I'm still going to put in negative 8 over 3. First of all, I make sure my calculator's in the radian mode. Don't forget to always do that. So I'm in the radian mode. And maybe you can see it here. So let's put in negative 8 divided by 3. And then I'm going to hit, for me, my inverse tangent keys right here. So this is negative 1 point. So this is like negative 1.21202 or whatever. But for my answer, I have to subtract that 1.21202. So for my calculator, yours will probably be fancier than mine. I have to sort of store this. And then I'm going to go do 2 times pi. And then I'm going to, so then it's actually 5, so 3 digits, 5.0711, so 5.071. So there's theta. All right, inverse trig function's a little tricky, especially when using your calculator. So here's r, here's theta. So in the polar form, the r square root of 73, cosine the angle in radians, 5.071, plus I sine 5.071. And then exponential form, it's just r e to the I times the angle in radians, 5.071. All right.